Hi all, let's see the next part of Unit 3, Computer Arithmetic. The first topic is sign magnitude, addition and subtraction. Coming to the contents, in today's lecture we are going to discuss about an introduction and algorithm of addition and subtraction, and then we'll see examples of addition and subtraction of signed numbers. Coming to the introduction, what do you mean by a sign magnitude representation? As we know, the number system consists of unsigned numbers and signed numbers. You can represent a positive number using a unsigned representation. But when you want to represent a signed number, that can be represented using sign magnitude representation. So the sign magnitude representation is a way to represent a signed number in a binary form. And how do you represent it? Using the most significant bit to indicate the sign of that particular number. So the most significant bit here is nothing but the leftmost bit in a binary number. If the most significant bit is 0, it indicates that the number is a positive number. If the most significant bit is 1, it indicates the number is a negative number. So, in a sign magnitude representation, the most significant bit is used to represent the sign of the number, whereas the remaining bits represents the magnitude of the particular number. So, that representation is called as sign magnitude representation. So, next, we'll discuss with an algorithm how to perform an addition and subtraction operations on a sign magnitude data. So here, if we consider the numbers as A and B, two numbers A and B, then we have to perform an addition operation or a subtraction operation on these two numbers. So we designate the magnitudes of those two numbers are stored in A and B, which has to be either added or subtracted. So when you see the different possible combinations of addition and subtraction operation, we get 8 different conditions to consider. And consider when both the operands A and B are equal, and when they are subtracted, the result has to be plus 0 and it should not be minus 0, because there is no such minus 0 existing in the arithmetic. So when you are considering both the operands A and B are equal, say I have an operand 5, A as 5 and B as 5. When I perform a subtraction operation, my result should be plus 0 and it should not be minus 0. That has to be considered. So when it comes to different conditions for addition and subtraction operation between two operands A and B, in case of an addition operation, my operands A are said to be called as A and B, where A is said to be called as your augend, we call it as an augend, and B is said to be called as your addend. When it comes to subtraction operation, which is A minus B, the first operand A is said to be called as a minuend, whereas the second operand B is said to be called as a subtrahend. So, if you consider the addition and subtraction of a sign magnitude data, we have 4 combinations for addition and 4 combinations for subtraction. So, in case of if you look at the addition operation, there are 4 possible combinations of the operands. In the first case, both the operands A is positive and B is positive. In the second case, A is positive value and B is negative value. In the third case, A is a negative value and B is a positive value. In the fourth case, A is a negative value and B is a negative value. Both the operands are negative, both the operands are positive. In this case, first operand is positive and second is negative. In this case, first is negative and second is positive. So there are 4 possible combinations for addition operation. Similarly, if you consider for subtraction operation, the same way, both the operands are same, which is either positive, both are positive, or both are negative. Or first is positive and second is negative, first is negative and second is positive. There are 4 possible combinations. So when it comes to, we'll see how an addition operation can be performed. So if you consider both the operands are positive, A and B, in that case, in case of an addition operation, I am going to add the magnitude of two numbers, operands A and B. You forget about the sign bit. we are considering here only the magnitude part of your sign magnitude data. So the magnitude of the two operands A and B are added, then and the resultant sign, the sign of the result will be the sign of A. So this is in case of addition when two operands are positive. So similarly, when both the two operands are negative, in that case you have to add the magnitudes of A and B, and the resultant sign will be the sign of A. Okay, this is in case both the operands are either positive or both the operands are either negative. And there are two other combinations. So let's see the first one where the first operand is a positive value and the second operand is a negative value. In that case, you have to check if A is less than B or A is greater than B or A is equal to B. So one operand is positive and when one operand is negative, the second operand is negative, we have to check if A is less than B or greater than B or equal to B. If A value is greater than B, say my A value is plus 40 and B value is 35. In that case, A value is greater than B. In that case, you need to perform A minus B. Okay, you need to perform A minus B and the resultant sign will be the sign of A. What is the sign of A? Plus. So, this is how it is performed. In case, if the A value is less than B, so say my operand A is 35 and B is 40. A is less than B. In that case, you have to perform B minus A. Okay, you have to perform B minus A and the resultant sign will be the complement sign of A. So what is the complement? What is the sign of A? Plus. What is its complement? Minus. So the resultant sign will be the complement sign of A. And there is other, if these two conditions are not true, then we will check for the third one. If A is equal to B, both A and B are having the same value, then you have to perform A minus B. And when you're performing a subtraction, when two operands are equal, you need to have a positive 0. So the resultant sign will be the plus. Okay. Next, in the third case where the first operand is negative and the second operand is positive. In this case, you have to check if A is greater than B. If A is greater than B, you are performing A minus B and the resultant sign will be the sign of A. Similarly, if A is less than B, you are performing B minus A. You are subtracting smaller number from a larger number B. You are doing B minus A and the resultant sign will be the complement sign of A. So the sign of A is minus, the complement sign is plus. And here the same thing, if both are equal, you are performing A minus B and you need to have positive 0. So this sign will be plus. So this is how you perform an addition operation on two operands A and B in all the four possible conditions. Coming to a subtraction operation, it is the reverse of addition operation. So if you see here, if both are positive, both A and B have the same signs, you are adding the magnitudes. But here in the case of subtraction, if both are having opposite signs, one is positive and one is negative, A is positive, B is negative, and A is negative and B is positive. In these combinations, here you are adding the magnitudes. So in case if the first operand A is positive and second operand B is negative, you need to add the magnitudes of A and B, and the resultant sign will be the sign of A. And in the second case, if A is a negative value and B is a positive value, then you need to add the magnitudes of A and B and the resultant sign will be the sign of A. So this is how you do. So when it comes to both positive and both negative, first consider a situation where both of your operands are positive. In that case, you have to check if A is less than B or A is greater than B or A is equal to B. If A is greater than B, then you are subtracting B from A. You are subtracting a larger number, smaller number from a larger number. So you are doing A minus B. And the resultant sign will be the sign of A. In case if A is less than B, you are performing B minus A and the resultant sign will be the complement sign of A, which is minus. And here, if both are equal, you are performing A minus B and you get a positive 0. So you are giving a plus. Similarly, if both my operands are negative, then we have to check if A is greater than B or A is less than B or A is equal to B. So in case if A is greater than B, I am performing A minus B and the resultant sign will be the sign of A. If A is less than B, I am performing B minus A and the resultant sign will be the complement sign of A, which is plus. Here, when both the operands are equal, I am performing A minus B, and since both are equal, I will get a subtraction as 0. So, I have to give a positive sign. So, plus. So, this is the algorithm for performing addition and subtraction operations on a sign magnitude data. And remember, when you are adding the magnitudes here, you have to consider only the magnitude part and not your sign bit. Okay, and because you already know what is the sign, so you need to just perform an addition or subtraction operations on the magnitude part of your data. Now let's see an examples of, based on this table, now we'll see an examples of how to perform an addition and subtraction operations. So first we'll see with an addition operation. So here I am taking two operands A and B, where my first operand A is a positive value plus 35 and second operand B is also a positive value plus 40. Now I want to perform an addition operation. So if you look at the previous table, when both of your operands are positive, A and B, so when both of your operands are positive, then you need to add the magnitudes of A and B and the resultant sign will be the sign of A. So I am going to add the magnitudes A plus B and resultant sign is going to be plus. So first I will take the representation of plus 35. So what is the representation of plus 35? 0. The sign bit is 0 and 35 0 0 1 0 0 0 1 1. And similarly, if you take a representation of plus 40, the sign bit is 0 and the magnitude will become 0 0 1 0 1 0 0 0. So I have to add only the magnitude part of my representation. So I am adding it 1 plus 0 1, 1 plus 0 1 0 1 0, 1 plus 1 is 1 0, 0 plus 0 0, 0 plus 1 1 and 0. So if you convert this into a decimal form, it is nothing but 75. Okay, and what is the sign here? As we know, the sign has to be plus. So this is plus 75. This is how you perform an addition operation on your sign magnitude data. Next, we'll see one more example where I am taking my first number, first operand as a positive value and the second operand B as a negative value. So my first operand A is plus 35 and the second operand B is minus 40. So when one is a positive and one is negative, I have to check if A is less than B or A is greater than B or A is equal to B. So I am checking, you check whether A is less than B or greater than B. So if you see, don't consider the positive signs, consider only the magnitude. So just consider the numbers. So B is greater than, A is less than B. So A value is 35, B value is 40, so A is less than B. In case if A is less than B, from the table, what we have to do? We have to perform B minus A. And the resultant sign will be the complement sign of A, which is nothing but, what is the sign of A? Plus. Complement is minus. So the resultant sign will be 1, minus. Now I have to perform B minus A. How do I perform B minus A? So you can write it as, so B minus A can be represented as B plus minus A, right? So B plus, so minus A is nothing but, you can represent it minus A as 2's complement of A. You perform a 2's complement of A, binary value of A, it is nothing but minus A. So what I can do is, first I will perform a 2's complement of A. So first we will take plus 35. So what is the binary value of 35? 0, 0. I am just taking the magnitude part. 0, 0, 1, 0, 0, 0, 1, 1. So I have to perform a 2's complement. To perform 2's complement, what I have to do? I have to first calculate 1's complement and add 1. So what is the 1's complement? 1, 1, 0, 1, 1, 1, 0, 0 plus 1. So it becomes 1, 1, 0, 1, 1, 1, 0, 1. So this is nothing but 2's complement of A minus A. So I have to add B to this. B plus minus A. So what is the value of B? So it is nothing but 40. So what is 40? The binary representation of 40. It is. So this is the binary representation of 40. So we can write it here. 0, 0, 1, 0, 1, 0, 0, 0. You add it. 1 plus 0, 1, 0, 1. 1 plus 1 will give you 1, 0. So this is 1, this is 0. So 1 plus 0, 0, 1 plus 0, 1, 1 plus 1, 1, 0, 1 plus 1, 1, 0, 1 plus 1, 1, 0, 1 plus 1, 1, 0. So this 1 is nothing but your output carry. Okay, you can neglect this. So this is your result. So what is your result? 5. So what should be your sign? So here the sign should be minus 5. Okay. So this is how you perform an addition operation on sign magnitude data. Next, we will see how to perform a subtraction operation on a sign magnitude data. So here I am considering an example where my first operand A is positive and B is also positive. In this case, according to the table, when both the values are positive, I have to check if A is less than B or A is greater than B or A is equal to B. So if you see here, just check the numbers, not the sign. A is less than B. And A is less than B from the table, it is minus of B minus A. So the resultant sign will be minus. I have to perform B minus A. So first I'll perform minus A. So for performing minus A, I have to do B plus 2's complement of A. Right? So what is the value of A plus 35? So what is the binary equivalent of 35? 0, 0, 1, 0, 0, 0, 1, 1. So I have to perform 2's complement. So I have to perform 1's complement, 1, 1, 0, 1, 1, 1, 0, 0 plus 1, which is nothing but 1, 0, 1, 1, 1, 0, 1, 1. This is nothing but minus A. So I have to add B to this. What is the B? B is nothing but 40. So what is the binary equivalent of 40? 0, 0, 0, 1, 0, 1, 0, 0, 0. Perform an addition. So this is B. B plus minus A. So 1, 0, 1, 1 plus 1, 1, 0, 1 plus 1, 1, 0, 1 plus 1 becomes 1, 0, 1 plus 1, 1, 0 and 1 plus 1 is 1, 0. So this is your output carry. You can neglect this carry bit. So this binary representation is 5. So when you perform subtraction of plus 35 minus of plus 40, your result will be minus 5. So what is the resultant sign? Minus. So it is minus 5. Similarly, I'll take first value as positive and second value as negative. In the case of subtraction, when one first is positive and second is negative, then you have to add the magnitudes and resultant sign will be the sign of A. So what is the binary equivalent of A? 0, 0, 1, 0, 0, 0, 1, 1. That is the binary representation of 35. Similarly, what is the binary representation of 40? 0, 0, 1, 0, 1, 0, 0, 0. Just add the magnitudes. So it becomes 1, 1, 0, 1, 0. So 0, 1, 0, 0, 1, 0, 1, 1. So this is nothing but 75. So what is the sign? The resultant sign should be plus. So plus 75. So this is how you perform the subtraction operation on sign magnitude data based on the table. So we'll see the remaining part in the next class. Thank you.